Hello, everybody, and welcome to Return Zero. This is part two of the overview of self hosting series, where we'll be learning from a high level what self hosting is and how it works. If you haven't yet watched part one, please go and watch that from the link in the description or the card I'll put on screen now. Thank you, and let's begin. Let's say you and a few buddies want to have a Minecraft server that you can all access from your houses. If you've seen part 1 of my video, you'll know that on the awesome self-hosted GitHub list, there is a section for Minecraft and other game servers you can host. We know that we need a server, but what actually is a server? Well, a server is just a PC. A server is just a computer that serves some application to the user. The user is also known as a client. A device can be both a server and a client, but for this purpose of this overview, we'll focus on server specific devices. The example we'll be talking about today is Minecraft, but the same concepts will apply to any type of server. Our friend Jim comes over to our house and asks to play Minecraft on the server with you. You don't have the server set up yet, so you tell him you can open your world to LAN. Our LAN, or local area network, contains all the devices that can communicate with each other without reaching the internet. The definition of LAN is a bit more complicated than this, but for now, this will work. In this example, the three computers, the phone, and the router would all be considered devices on the LAN. Jim's PC at his house might be connected to the internet, but would not be considered a part of our LAN, as we need to get to the internet to play on his PC with him. In Minecraft, to make your application accessible to the LAN, you click the Open to LAN button. This outputs a message into the chat and gives you something called a port number. Just like every device has a specific IP address, which is just a number to identify the device, every application also has a specific port that identifies the application. In this case, the application Minecraft is identified or mapped to the port 54,145. We could also host something like Palworld, Ark Survival, Rust, or any other application, and each one will have their own specific port number. This makes it so we can use the same server to host multiple applications. With this information, we still need the IP address of the server for Jim to connect. To find the IP address of the server on Windows, we open up Command Prompt and type ipconfig. This gives us a lot of information, but what we're interested in is the IPv4 address. After getting the IP address and the port, we're ready to help Jim connect on one of the other computers in our LAN. For Minecraft, we can open up multiplayer and click Direct Connect. By putting in the IP with the colon, we're telling the application we want to connect to that IP and that specific port. After we click Join Server, we should successfully connect to that IP and port. If you run into any issues, it could be your server or PC's firewall blocking your connection. This means that we've successfully connected to Minecraft on our LAN, and now Jim and us can play Minecraft together. But you and Jim have a good time playing Minecraft for a while, but his mom calls him home for dinner and says he can't spend the night. But Jim really wants to play Minecraft on the server with you from his house. So let's figure out how to do that together. Well, we know that you and Jim both have internet connections. This is something we can generalize as what's called a wide area network or WAN. A WAN, like a LAN, is a network, but with one key difference. The difference is the distance between each device in the LAN. A local area network contains only the devices like your personal PCs and phones, whereas the WAN would include Jim's PC as well. A lot of the times, people will say WAN as shorthand for the internet. There are many more types of networks than this, but we won't be covering all those in this video. We know that Jim needs to connect to the Minecraft server across the WAN or across the internet. To do so, we first need to understand which PC is our server and the IP address Jim needs. If Jim goes home and tries to type in the same IP address and port combination he used to connect at our house, it won't work. This is because he's trying to connect to a LAN device while being on a different LAN. In other words, he's not on the same network as our house. So, we need to figure out what the WAN IP address is for us. In other words, the IP address that identifies us on the internet and not on our local network. To do so, you can type into Google or any search engine and search what is my IP address. There's also a site called what'smyipaddress.com, and this will give you your WAN IP. Once you have this, you're well on your way to getting Jim onto the server from his house. This IP is the address that your router uses to connect to the internet and therefore identifies your router. Now that we know the IP of our router, we can configure our router for Jim to access the Minecraft server from his house. To do so, we can use something called port forwarding. Port forwarding, also called port mapping, is one easy way for you to expose your applications and services to the internet. Port forwarding uses something called NAT, which stands for Network Address Translation. We know that Jim can't connect with our LAN IP of the server, so this means we need to somehow convert it into an address that Jim's router can understand. Our router takes care of this for us and converts the address and port into one port that is exposed by the router. In our case, we have an IP of 172.26.164.45 and a port of 54.145. We refer to this as the internal IP and port, and we know that our external address, or WAN IP, is 125.164.46.33. To configure port forwarding, we'll need to log into our home router and edit some configuration settings. To access our router's configuration page, we'll need to open up Command Prompt on Windows and type in ipconfig again, instead of the IPv4 address. Now we'll want to look at the default gateway. We see that our default gateway is 172.26.160.1. We'll navigate to this IP in our web browser, and it should pop up with a login screen. Hopefully, your router is configured with a secure username and password. After entering those, you'll be greeted with a setting page. Unfortunately, this will be specific to each router, but the general steps should be as follows. Enter the NAT/port forwarding configuration page, then enter the LAN IP of your Minecraft server. In our case, 172.26.164.45 and the internal port of 54.145. We can set it to any external port we want, but there are default ports for most applications, including Minecraft. The default external port is 255.65. We'll set our router to this port to make Jim's connection easy. Save those settings and enable the entry in your router, and Jim should be able to connect to your Minecraft server. We'll tell Jim our WAN IP address and ask him to connect to our Minecraft server. If we set everything up correctly, he should be right on and playing on our Minecraft server from his house. While port forwarding is an awesome way to let Jim connect to our Minecraft server, there are a few drawbacks to having him connect in this way. Opening a port on your network is like leaving one of your doors open. This has the potential to let threat actors, i.e., hackers, into your network. What's running on an open port is what's important. If there is ever a vulnerability in the application you're exposing, the device and everything on your LAN will be potential vectors for a hack. Another thing is anyone can access the Minecraft server from the internet. It's like handing a key to everyone in existence to your house. An example of the vulnerability would be Log4j. Log4j was a bug in Java that allowed attackers to run any command on a server by sending special requests to it. If somebody got the IP address of your Minecraft server from Jim and you were running this version of Java, your Minecraft server would be vulnerable. In part 3 of this series, we'll address some of the security concerns of port forwarding by diving into how reverse proxies work and how they make life as a self hoster more secure and easier. Thank you all for watching. Be sure to like, comment, and subscribe. Keep an eye out for part 3 of this series, which should be coming out tomorrow. Don't forget to drink water, eat food, and take care of yourself.